Welcome back again. This is another video session talking about the Creative Technology Toolkit, and this is session 2. This week we are going to be talking about images, video, and complex input. Again, the source code for this session is available from GitHub, UWE Creative Technology in the CT Toolkit sessions that you can download and work on yourself using C++ and openFrameworks. So I've downloaded this as we did last session, and if I come to my toolkit sessions, in session 2 I'm going to launch Xcode, but again this will work in whatever your development environment is. So this week I'm going to try and run through it fairly fast. All of the code is commented, hopefully reasonably well and sensibly. In our source folder, we have main CPP, which, as we know, boots an OpenGL window and runs our openFrameworks app, which calls in our header file. And in here, this is completely standard, but in the header file, I've added a couple of simple new things. What I've done is I've made an instance of the OF, the openFrameworks video grabber, which is an object that openFrameworks knows about that can grab video. So I ask it to make an instance of the openFrameworks video grabber, and I've just called it vidGrabber. So that's now available to the whole program, providing it initializes. And then I asked to make two variables that are going to be available to the whole program, an integer called camWidth and an integer called camHeight. There's a couple of other things in here which you can uncomment as we go through and add elements. But this is the basics. I've asked the video grabber to make a video grabber and called it vidGrabber. I could call it Fred or Jane or whatever else I like, but I like vidGrabber, it seems to make sense. Integer width, integer camHeight, and in the openFrameworks main app C++ file, this time in the setup function, there's lots of comments. All I've done is I've used OF background to set it to 0 red, 0 green, and 0 blue. Let me zoom into the code a little bit here, make this a bit bigger, get rid of some of these things that we maybe don't need. So, in the setup, it runs openFrameworks, OF background, sets the background to be black. And then because we've made these two integers, we want to initialize them. Otherwise they're null, and if we called them, we might get a load of garbage coming back. So we're going to set camWidth to 640, camHeight to 480. And these are common values that video cameras will grab native. Increasingly you see larger sizes, 1080 and so on. But I know these work for the Mac. If you get errors for your platform that has a camera, go and double check the standard ratios or resolutions that the camera will grab at, because the vidGrabber wants to work at one of those. It'll usually be 320, 240, 640, 480, 1080, etc., and a multiple of those. But I know this works on most Macs and PCs and Linux. It's a fairly standard size. And then I'm going to ask the vidGrabber object to do a particular thing, and I can ask the vidGrabber object to do some stuff that it knows about. And one of those is I'm going to set verbose to be true, and verbose means that it's going to be quite wordy, and when it gives me errors or tells me about what it thinks it's doing, it's going to give me lots of detail, which means if something isn't quite working and I can't talk to my camera correctly, hopefully it'll give me a lot of information to help me out. Then the next thing is I tell the vidGrabber that we've made to set itself up, and setup is a thing that it knows how to do, and I tell it to set itself up to be the camWidth and the camHeight. So I say grab yourself, set yourself up to grab images from a video camera that's attached at this width and height, and then that is the end of the setup. There's some things that we're going to come back to in a minute, but just for now all we've done is we've made a video grabber instance called vidGrabber, we've changed the background to be black, and we've told the vidGrabber to set itself up to a particular width and height. All being well, openFrameworks now can talk to the video camera. In the update loop, what I need to do is ask the vidGrabber to update itself. It knows how to update itself, and what that means is it'll go to the video camera and say, are there any new frames? And if there are, it'll pull them. if we don't do this, it doesn't ask the video camera if there are more pictures. We just keep having the same still picture. So we need to update in this update loop that's running all the time. Go to the video grabber object and say, go and ask the camera, please, are there any new frames? In the draw loop, there's lots and lots of comments, but it's only actually doing one thing. We're asking the vid grabber object to draw itself, which is the thing it knows how to do, at a pixel position. And the pixel position is 0, 0. And the only other thing is in this loop, and this is a function that listens to the keyboard essentially, and is waiting to see if a key has been pressed, and then it'll provide an integer called key with the number of the key. And I made a simple statement here to say if the key is equal to S, lowercase, or uppercase S, set the vidgrab settings, which it will set up and output the video settings for me into the console window. So if I run and build this now, let's see what we have. So the build has succeeded. As you can see, it's much quicker than last time because we've already compiled most of the code. It's only these extra source files that are new. And bingo! We have our openFrameworks application window, and there is picture in picture, me in picture of a picture in a picture. I have a video image, and that's coming in, and I can move that around the screen, and it's running, and it's 640, 480, and with different quality cameras and different styles of cameras, I can do different things and get different sizes and so on. Now, what I'm going to do now is show you what's cool about that. I'm going to start out in OF draw, and here I can change the video alpha, which is the blending amount of this whole video based upon the X position of the cursor. So I'm going to uncomment this, and I'm going to come up into my setup and just set up one more thing. Alpha blending takes a bit more processing, so generally it's switched off by default. So I use this command in my setup. So this is a setup function. Enable alpha blending. It just means switch it on. And I can disable alpha blending if I'm not using it. By default it's switched off. But this is a thing that openFrameworks can do that allows us to blend objects together on the screen, which is very cool, and it does it very, very fast. And I'm saying make me a new float, which is a decimal number, as a variable called video alpha value. And the video alpha value is going to be based upon the mouse X position. And what I want it to do is give me a value between 0 and 255. That's the blending value. 0, 255, from minimum to maximum amount of blending. And I want to use the coordinates left and right of the mouse to do that. And I can use this very useful function called oFmap. And basically it maps one set of things to another set of things. So if I said, oh, I have a value between 0 and 1000, but actually I need a value between 0 and 1, but based upon the same thing. So if I had a dial that gave me a value of 0 all the way to 1000, but I wanted to control a light that only goes from 0 to 1, I could say map me 0 and 1000 to the values of 0 to 1. So when the input of, say, 500 halfway around the dial was passed to the map, it would remap it and say, well, that's halfway, which is between 0 and 1 is 0.5. And with oFmap, you tell it what the input value is coming from, in this case it's the mouse X, and what the possible range of that is. And the mouse X can go from 0 all the way across one side of the screen to OF get width, which is going to tell me dynamically the width of the current screen. So it says to openFrameworks, please go and find out the width of the screen, which is very cool. So I just say, take the input of where the mouse is, and the possible values that it can be are from 0 to whatever the current width of the screen is. Take that range and remap it so that it's in between the range 0 and 255. So I take the X position of the mouse and turn it into somewhere between 0 to 255 and set the video alpha value to that. And then in this line here, I set the color to be white and with an alpha channel. So I've got my RGB, red, green and blue, and then a blending value at the end. So it means I can have blended colors, which is really cool. So I've set that, and if I press play or press build now, this should build. And when I move my mouse left and right, it fades the video in and out by changing the alpha blend value, which is also enabled using set enable blend value, which is kind of cool. So now I can blend objects and do things dynamically, and we've seen how we can map a range of input values to something else. Now we're going to get funky and we're going to do some dumb stuff to the video. What I'd like to do is actually make the video inverted. So whites are black and blacks are white. And this is like an old video effects trick, but we can do it digitally because all that the pixels in the video are is a value. So if I chose an individual pixel on the screen of my picture, I can go to that individual pixel, 100 across and 100 down, and say what is the color of it. And it's going to have a red value, a green value, and a blue value between 0 and 255. And if I inverted them, I get the opposite of what that color is. So I could draw a negative image, which is exactly what we're going to do now. So in my setup, let's double check. In my header file, there are a couple of things that I'm going to set so that they're available to the whole program. So I come to the bottom of the header file where it says these are the parts for our inverted video hack. I'm going to make an OF pixels object. And an OF pixels object is an object that just knows what pixels are, which means I can put pictures inside it. So it's not an image that I'm going to necessarily draw straight to the screen, but an image object has pixels inside it. But it's a whole load of picture elements, pixels. And then I'm going to make an openFrameworks OF texture object, which is similar. But the texture thing I can also use for wrapping onto 3D objects, but basically they contain picture information. So one's called video inverted and the other's called video texture. We'll look at these later on and see some of the differences between them, but at the moment we're just going to make one to hold our video that's been turned inverted and the other to have a texture inside it. So we've made them now. One's called video inverted, the other called video texture. And in our CPP file, in our setup, we need to allocate these objects to say how big they are before we start putting information in. So we need to initialize them. So I'm going to uncomment these lines. The first one is I'm going to take the object that I made, video inverted. I'm going to tell it to allocate some space to put a picture into. And I'm going to make it the same width and height as we're using to grab images from the camera from. So I know if I get an image from the camera, it's going to be a width and a height. And if I tell it to copy itself into the video inverted object, all the picture information, it'll be the same. And then I tell it what kind. And it's going to be pixels that are red, green, and blue. It could be grayscale, and there's other kinds of more complicated images that have more information in. But we give it a width and a height and the amount of data per pixel. The video texture, going to do the same. I'm going to allocate it, but when I pass it an object, it just copies itself. So I passed it video inverted, so the video texture will also be the camera width and the height, and is going to be pixels RGB. And then just to help me synchronize, I'm using this thing of set vertical sync, and I'm just saying switch it on, and it'll synchronize all the drawing of stuff on the screen. So I've made a video object, which grabs the video. I've made an additional picture object called video inverted. That's the same size as the picture that's coming from the camera. I've made a video texture that's the same size again. In update, here's the section that's going to do our cool video hack. So I'm going to shift and uncomment all of these. And here I've got an if statement. I'm going to say if video grabber is frame new, and it'll go and ask the video grabber, you did an update, have you got a new frame? If it says yes, I'm going to say the pixels, make a new pixels object and get the pixels from inside the video grabber, so it gets all the picture data, and put it into this object pixels. And then I'm going to say find out how big it is, which is how many pixels are there in the whole thing, from the first line all the way across the top, every line going down, and down and down and down and down to the last pixel as a long list, which means it's going to be 600 times 480 pixels. And this loops through this for loop from 0 until I is as big as the amount of pixels inside the image. And I'm going to say make the pixel in the video inverted object at whatever I is. So we start at pixel 1, pixel 2, pixel 3, pixel 4. Read from pixel 1 in the pixels object and set the pixel 1, 2, 3, 4 in the video inverted object to be 255 minus the color at pixel whatever I is. And it'll go through that, reading the value of an individual pixel one after another and inverting it. And then when we've looped through all thousands of pixels, because of how we're drawing, we load the data from video inverted into the video texture, and then the video texture we can draw onto the screen. And then when I come down here, after we draw the video grabber in our draw loop to the screen, I'm going to say, well, this new object, the texture object called video texture, we can draw that places. So please draw it onto the screen and start at the cam width across. So it'll not draw at 0, 0, which would draw it over the existing video image. We want it to draw it 1 across, so we know how wide the video image is. So we tell it to draw across, and we tell it to draw camera width and camera height at the top of the screen. So all being well, I tell this to compile. Sounds like Bristol's exploding tonight. And here we go. We've got our left and right fading. My hair looks very cool. Thank you very much. And from one side of the other to the other, we're going through and reading the value of every single pixel in the video image, inverting it by taking away from 255, so we get the opposite value, and then we're writing it into the other image. So we have live a color image and a completely inverted image. And you can see we could do all kinds of things with that. We could restrict the colors. We could say go through and make every color above this white, every color below this black, or ignore everything and only where there's this color, put it in. So we can start to manipulate the image based upon a whole load of stuff. We could even say, oh, take an input from what the weather is and change the color. We could take an input from the sound and have it going up and down and changing the color values or the brightness or all kinds of things. And it allows us to build video manipulation really simply. And what's cool is we've seen a loop of how we can go through a large block of data, such as an image, which is line after line after line of color values, loop through, and really fast. This is live, processing tens of thousands of pixels. Now, there's one more thing that I want to do, which is even cooler than this. And it's really good for making profile pictures and stuff. So I'm going to come back in, and everything is ready in our header file. But there's one more little bit that I'm going to uncomment. I'm going to say, I want to make a string, and a string has text inside it. So if you wanted to put the name of somebody in, you would make a string, and then you can put text inside it, just in the same way that you put a whole number into an integer variable, or a decimal number into a float variable. So I'm going to say, I want to make a string that's going to have some text inside, some text characters, and I'm going to call it ASCII characters. And ASCII is the American Standard something instructional. Blah, blah, blah. Basically, it's a standard numbering for standard characters off a keyboard, A to Z, and full stop and slash and so on. And then I'm going to make an object called OF TrueType font. And this is an object we can say, please, can you go and find a cool looking font and load it in so we can use it inside our applications. And I'm just going to call that font. I'll need to initialize that in a minute and tell it what font it'll be. But if I want to draw in anything other than the standard boring system typeface that openFrameworks knows about, I can call a custom typefacing. So I've made a string and I've made a font object I'm going to put a font into. So in the setup, I use a method that the font object understands, which is font load, and then I tell it the name of a TrueType font, and I tell it the size I want it to be as standard. And if I flip to the session 2 folder, in the binary folder, there's always a data folder. And that's the first place our application will look if we ask it to load any extra stuff. We could tell it it'll be somewhere else, but in there is the font Courier New Bold. TTF means it's a TrueType font, and that's a particular kind of way that a font is described. And Courier looks like this, and this is a standard explanation or shape. What's cool about it is it's called a monospace typeface, which means the width of every character is the same. Even if it's an I, it takes up the same amount of space. If it's a 1 or a 0 or a dot, which means, as you can see, all the letters line up, which is why it's like a typewriter font. It's often used for code, etc., so that you can read up and down through the lines. But for our purposes, it's ideal. We want something that's got a standard grid. Everything's the same width. So we use this in the setup and say font load, please. Tell it the name of the typeface and tell it the size. And then we're going to put some values into our string, ASCII characters. And here it is. We're going to say ASCII characters equals this long string. And I've put it in quotes. It wraps around 2 lines, but it's actually one long line. If I shrink the text down, you can see it should ping. It's actually one long line, but I'm going to zoom in. And this is taking standard ASCII characters and printing them in order of how dark they look, like how much ink, if they were printed, would they take up, with the full stop down here taking the least, all the way up through medium, with Q taking the most. And we're going to use these to represent light to dark pixels in our image and map these characters to different levels of light inside our video image, which is kind of super cool. Right, everything's okay. In the update, all we're going to do is we're going to grab things from the video camera, and we've got this if we want to keep running it, where we're saying grab stuff from the video camera, loop through every single pixel, swap it and put it over here into this new video object, and then draw it to the screen. Now, what we're going to do is here, uncomment this section to enable the ASCII video effect. You can see where this is going. We make a new pixels object and we get all the pixels from the video grabber and put it in there. Then we're going to make a color. And here we're going to make a loop. So I'm just going to take all of this and uncomment it and walk you through it. So we make a loop that loops around across the camera width, which is the width of the picture. And rather than looking at every pixel, we're going to look at every I plus equals I plus 7, that's what it means. Every 7th pixel. Because when we ask to use our typeface up here, we said we want to use this monospace typeface at 9 pixels. It means it's going to be 9 pixels high, but every letter, every character is only 7 pixels wide, but they're all 7 pixels wide. So we want to turn every 7th pixel in our image into a letter. So we say just loop through, jumping. So if we were to print out the value of I in our loop, it would go 0, 7, 14, and on and on and on. inside this, as we're jumping across every 7 pixels across the width, we want to go down successively line by line. So we want to jump across till the end of the image, then go down a line and start again, jump across, down across, down across, down across, down across, like going through a grid. So inside our first loop, we have a second loop where we're using J as the iterator. We start J at 0, and J is going to run until it gets to the camera height because we want to go down line by line. But this time it's going to jump 9 because the height of the text, the letters we're using is 9 pixels. And then when we go across and then down 9 each time, we say make a value that we're going to call the lightness, and this is going to be a decimal value, and look at the pixel that we made and transferred all our stuff here out of the video grabber, get the color there at this particular point, and get its lightness, which is a thing that it can do. So it tells us the light or the dark value and brings it back, and that's in lightness. And then we're going to use map again to say we're going to put input lightness. That's our value coming in, and lightness can go from 0 to 255. And then what we want to do is have a map of 0 to 1, and then we look through our ASCII characters and find out how many characters is in that string. If there's 50 different letters that we're using in there, give me a number between 0 and 50 and pick one. I can't remember how many there are. There's 28 or something, 27, 30. It's going to find out the size by using ASCII characters dot size, and that returns the size of something for you. And then it's going to pick which one is that character that corresponds to where we are from 0 to 255 in the lightness scale. And that's going to be in character. And then we're going to tell the font to draw a string. And we're going to take ASCII characters, character number, whatever the number we just found out that we should be picking, and tell it to draw it on the screen at that point. So we've got a couple of different things going on. We're making a loop that goes along every 7 pixels. Inside that, every time it gets to the end, it goes down 1 because there's another loop inside going this way, jumping down 9 pixels at a time. And we grab the lightness, light to dark, from that particular pixel, wherever we are, 7 across and 27 down, from the video grabber, where we're grabbing the pixels out of our video grabber image. So we know how light or dark an individual pixel is anywhere in this coarse grid of 7 by 9. And then we say, okay, get that value and use our friendly map function to choose which character out of this list of ASCII characters of letters should we use to represent that. And then use our TrueType cool monospace typeface courier, draw the string to the screen using that particular character at this location, and I and J gives me a value from 0 640 across and 0 to 480 down in that grid. So it'll just draw that character at that position, which is very cool. And all being well, if I run this now, so this is compiling. That is very cool. So that is me represented in ASCII. And underneath, my left and right blend still works. So you can see I have my color image from the video grabber. I have my black and white inverted image that I'm pulling from the video grabber and subtracting 255, the pixel value from 255 all across to make it inverted. And then over the top, I'm using the pixel values that I'm pulling from the video grabber, analyzing the lightness of every 7th one going across and 9 down, and saying, if that were done on typewriter of this scale of a dot being very, very light and a Q being very dark or inverted, what would that look like? And now I have my my ASCII video grabber. So that's it for this session. Go through, there's several elements, go and explore. Find out what happens if you invert the value here. What does it look like with white and black? Play with the colors, explore a little bit. In this, you've seen we can make a vid grabber object and bring video in. Now we can bring video in, and as we're showing here, we're not actually drawing the video to the screen, we're manipulating it in some other way. We don't necessarily have to draw video and show video to do something with video. And it could be that I can say, actually, this can be a series of sounds. Or it could operate a number of motors or sensors or actuators or 1,000 washing machines that are connected through a power bank that openFrameworks is switching on and off, or any kind of craziness. So this is how we can get complex data in and manipulate it and be able to go through and start doing translations based upon the information that's in there. So until next time, me, my ASCII me, and my evil inverted twin me, thank you very much.